To warm up, friends, we're looking at the average daily temperature, or the average temperature in Toronto in February. Above listed here are the guesses. You'll see the guesses people made here. It is up to you to plot how far they were off from the actual, which is 0 degrees. It's Celsius, so it makes sense. You're going to use that information to sketch it on the graph, and then do your best to write a rule explaining your inputs and outputs. All right, y'all, I'm going to start working on my dot plot, and you're going to help me out. 5 is how many away? 5. Okay, 2 is how many away? 2. Negative 5 is how many away? 5. 3 is how many away? 0, 0, negative 1, 1, 1.5, 1.5. 4, 4. Negative 2.5, negative 2, or positive 2.5. 6, 6. 4, 4 is negative half, negative half. What do you notice about the shape of our graph? V. In last class, we found out that's called an absolute value function. It's still an absolute value function, just like last class. Okay? What do you notice about our vertex? Where does it start at? 0, 0. Not a coincidence. We're seeing how far away it is from 0. Let's try to write a rule. Who can put a rule into words for us before I even try to write this rule? Like what's happening to all my inputs? Emmett?
The input is also the output. Like 5 is always 5 away.
Yeah, but negative 5's output wasn't negative 5.
It was though. Oh wait, never mind.
Okay.
The output is always the
Absolute value.
absolute value of the input.
Yeah, so I'm going to say this. The output's always the absolute value of the input. All of them are positive. There's another way we can state this too that we'll see in a moment. And let's test it out. If I put 0 into my function, what do I get?
0.
If I put negative 5 in my function, what do I get? I get positive 5. If I put 3 into my function, what do I get? 3. So the output is always the absolute value of the input. Yeah.
Is the 2 lines just the absolute value?
Yeah, these are absolute value symbols.
So it's the same thing as the guessing error?
Guessing error is like a specific type of absolute value function. Yeah, but they're both absolute value functions. Yeah. Excellent. So we're going to take it one more step here. This will be on the back of that notes page you have. We already know this from last class. An absolute value function makes the V. And I think we already know what a vertex is as well. It's that point. Okay? There's also a vertex. We'll do these later in the year, but this is a quadratic function. There's also a vertex on those. What you're going to do now is something similar but different. We're looking at distance from 0 on a number line. So this time, same thing, but not temperature and context. I want you to complete the table, and then this is where things are going to get interesting. Andre and Elena are both right with the rules they wrote. Andre wrote piecewise. Elena wrote function notation with absolute values. They're both right. So it's your job to make sense of how they're both right. So focus on the table, the graph, then make sense why they're both correct. And I'm going to let you know, focus up. Andre's is trickier at first for most people. Doesn't mean you can't do it, okay? So you got to figure out why is Andre right. Make sense of it. I'm going to start filling out the table. 8 goes in, 8 comes out. 5.6 goes in, 5.6 comes out. Pi goes in, pi goes out. Half goes in, half goes out. We got 1 goes in, 1 comes out. 0 goes in, 0 goes out. Negative half goes in, half goes out. Negative 1 goes in, 1 comes out. 5.6 goes in, 5.6 comes out. And negative 8 goes in, 8 comes out. So you would notice like right here that could be 8, but I already had 8, so I just chose to get one of each. Okay. Then I'm going to graph all these things. So I got 8, 8. I'm not going to do all of them actually. You have to do all of them. 5, 5. We'll do 3, 3. 1, 1. Half, half. 0, 0. Negative half, negative half. Negative 1, 1. Negative 5, negative 5. So I'm just not doing decimals either for me. Okay. What do you notice about the shape? It's a V. It means this function needs to be an absolute value function. Okay? It still is. We can see that V. Now, Let's try to make sense. I think Elena's is kind of all right. We just looked at that last. Does anybody need help explaining Elena's? If a number goes in, it always comes out as a positive, right? Which means regardless of what Andres looks like, it's also true for Andres. Whatever goes in comes out positive.
You just represented it with slope and inequalities.
Yeah, I think his is tougher.
Just making it more complicated.
Not more complicated. It's piecewise, so it's different. What this is saying is, this is our output if our input meets these criteria. So, the top one's easiest. If we have a number bigger than 0, is that number positive or negative? Positive. Positive numbers in an absolute value function always come out as positive. That's what this says. Is 5 bigger than 0?
Yes.
So it comes out as 5. Is 1/2 bigger than 0?
Yes.
So it comes out as half and so on. So that top one's easier. This bottom one, I wouldn't say it's harder, but it's different. So this is saying a number goes in and it's less than 0. So what types of numbers are less than 0?
Negative.
Negative, which means something like a -2 goes in. What should come out? 2, because the opposite of -2 is 2. So that negative in front, if it's the opposite of x, this is saying x is -2. What's the opposite of -2? 2. So this is making it always positive. It's saying the same thing. Well,
So pretty much, Andre's second equation is just negative number goes in, positive number, opposite of it comes out.
the opposite of the negative comes out, which is a positive. Yep. It's a little tricky because some people see that negative and it looks like negative comes out. But this is saying a negative number has to go in. This is saying the opposite of that negative comes out, which is always positive. It's not like trying to confuse you. That's the only way to do it in this way, to make it say always come out positive. Micah.
So when we're filling out the table, the negative eights that you put at the bottom, you both negative eight and eight.
Yeah, I just saw a +8 there, so I threw a -8 there just to balance it out, kind of. But a +8 there is not wrong. Okay. So don't go student.decimals for this, decimals.calculator, or just Google decimals calculator. Again, you're looking at what happens when you mess on the value on the inside versus the outside, and the slider is a nice tool to do that. So friends, I would be messing with the laptop here. Let's focus on the f of x function. And so notice I'm messing with the inside. So as I add numbers, those would be positive numbers, right? So I should send my slider to the right. Watch what happens when I send my slider to the right. Which way does my vertex go? Left. In fact, when I'm adding 6, my vertex is left 6. And here's why. If I'm inputting -6 here, how do I get back to 0? 6. -6 plus 6 is 0. Okay? Now let's go back to 0. And I know it says plus, but if I go negative, it's actually like what then? Minus. So look what happens when I subtract from x. Which way does it go? It goes to the right. And that's because if my input were to be -6, let's say, right here, -6, how do I get back to 0? Plus 6. Plus 6. So the general rule here, I'm going to write it down before we go to the next slider here, because I'm going back and forth between iPad and laptop here. Let's put that back at 0. The general rule for a there being on the inside for function f of x is, you can see, for x plus a, adding sends us which way?
Left.
And subtracting sends us what?
Right.
Yeah. And that's to reestablish 0 at the vertex by doing the opposite. Okay? For that x plus a. We saw when we moved the slider positive, it moved our vertex left. We saw that when we moved it negative or subtraction, it moved our vertex right. Everybody has these general ideas down on their notes? Because we're going to use these. We all good? Because I can show again on decimals if I need to. In fact, maybe when you finish the 2 rules, you go mess with them and make sure you can get it to match. So let's mess with outside. So g of x. So when I go positive, look what happens to my vertex. Up. And when I go negative, look what happens to my vertex. Down. That's because it's unrelated to the absolute value portion. My output is going up y value up or y value down, depending on what's added or subtracted to after. So I think that one's easier.
Wait, but then why from the top one does it, and when it's positive, it goes?
Because you have to re-zero out with the absolute value. So you have to kind of undo. Yep. So this one's affected by the absolute value, the top one, Raymer. The bottom one, that input is not affected by the absolute value. Okay, so the general rule we're going to have for g of x, which is the absolute value of x plus b. So when adding, it goes what?
Top. Where?
It goes up. When it's outside. When subtracting, it goes down.
Is it like the y-intercept?
It does behave a lot like the y-intercept, but it will not be the y-intercept. It's in reference to the vertex.
Wait, so are A and B are inputs, or are they?
A and B would be, no, other values to get to the output. X is the input. F of x is the output. Okay? Yeah, so what I want you to do is, again, we're going to summarize real quick. I'll summarize. When we add to the inside, it sends my vertex left. When I subtract to the inside, it sends my vertex right. You have that written down. When I add outside of the absolute value, it goes up. When I subtract outside the absolute value, it goes down. I want you to take 30 seconds to a minute here and just make sure you can make sense of that using your slider. Make your slider match what our statement says. Okay? And then we're going to get a little more practice with it as well. So we're just going to talk about, and we're going to use this then to help match in a moment. So computers down. We're done with computers for this lesson now. Okay, so when we look here, is anything happening inside or outside? No, so guess what? Right on the vertex right on the origin. Right here, I look at this and I see right 2. Check it out. Right 2. I look here, I see left 2. I look here, I see down 2. I look here, I see up 2. It's always in reference to the vertex. And just know there can be stuff happening inside and outside. I could go right and up, or left and down. Okay, it's not just one at a time necessarily. So where you're going to get a little practice. I know this is fresh, this is new. You're going to work on matching. So again, there's one that won't get used. You're going to try to draw that on your notes. What I'm going to do is I'm going to look at the graph and tell you how I know what it is. And I'm just going to write it. So, for this first one, I see that it went down 6. So nothing's happening inside my absolute value. I'm going to subtract 6, down 6 for my vertex. All right. The second one over here, I see that it went right 3. So I need a minus 3 inside my absolute value. Now this is the most common wrong. People will put plus 3. Here's all you have to do. Do we all understand that vertex is 0.30? Okay. That means input 3 gives me output 0. So if I put 3 into here, 3 minus 3 is 0. Input 3 gives me output 0.
It's basically saying what do you need to subtract or add to get back to 0.
Yeah. So let's say you messed that up and put plus 3. 3 plus 3 is not 0. Okay, so you can always check it by substituting a vertex. Okay, now this one is kind of fun. This one went left 3 and down 6. So to get left 3, I'm going to say plus 3 inside my absolute value. And then to get down 6, minus 6. Let's check it out. Negative 3 goes in, right? If negative 3 goes in, what needs to come out?
0.
No. Negative 6. So negative 3 goes in. What's negative 3 plus 3? 0. Minus 6. Negative 6. My vertex works. So if you get it, always check it. This last one went right 9 up 3. Okay, so to get right 9, someone help me out. How do I get right 9? X what? X minus 9. How to get up 3? Plus 3. Okay, which one didn't get used? The X plus 3? Okay. This one did not get used. So guess what this one says to do with my vertex? Left 3. That's good. And let's say you're like unsure. Like why? Why is it left 3? Well, let's check it out. That gives me my vertex at negative 3, 0. Let's test it. I throw in a negative 3. What's negative 3 plus 3?
0.
Okay. It's to make that 0 out on the vertex thing happen. Okay? There's only the two major things. If I'm inside the absolute values, inside, plus makes me go left, minus makes me go right. Because that involves zeroing out. It's the absolute value. The thing outside, not getting absolute value, would send me up or down accordingly. So we're only looking at shift right, left, up, or down. That's it, guys. That's everything.